buttons. Hopefully, if you watch this and then go to this worksheet, this will help you. But we're going to do several of these, and I'm going to do several with these with you, and I'm just going to sit and then explain strip diagrams. What you need to mainly know is that top strip, that longest strip, is your entire whole. That represents one whole. That's the total of everything. And every strip underneath it needs to either add up or represent the same as that top whole. Okay? So when we look at number one, and we're going to be doing this page where we're going to write equations to show each strip diagram and solve for x and match the answers with the letters below to answer the question. So what kind of buttons won't unbutton? And when you're done, down below, if you put your answers, the letter it tells you next to the answer, it will tell you that answer. So it's kind of a little bit of a fun worksheet here. Let's look at this first equation, okay? This one right here. I love these kind right here. And when you recognize and you look at these types of questions, you see that there are 312 as the whole. That somewhere represents the total. And all of these pieces, they have an X here because X just represents the variable. It's an unknown. It just represents, they're just putting a letter in there for the question mark. We don't know. It could be any number and we don't know what it is. Okay, so in here, and hopefully there, maybe you can see it better this way. This is the whole, and they have the whole. What are they doing to this whole? They are separating. And I know that they're in equal parts because these boxes are all equal. So how are they separating these? Well, they put it into 1, 2, 3, 4, 5, 6. Now, each of these pieces are smaller than that whole, so I'm going to think, what makes a number get smaller? Hopefully you're thinking already subtraction and division make a number go smaller. So if I'm looking for a smaller box, and I know what that big, huge top strip is, I know I'm going to be subtracting or I'm going to be dividing. But since they're putting into equal groups here, I'm going to be dividing. So here's the equation that you need to write. We're going to take the total. When you see this type of a strip diagram, oh my goodness. Let me pull up, give me 1 second. Let me pull up on my board so that I can write. If you will pause that video, I'll be right back. Okay, sorry about that. I got that working again. Ooh, face right up in there. Okay, so we said that there were 312 total. And to find out what the bottom part is, so this is part of my equation, this is going to get smaller, and since I'm putting it in equal groups, we're going to divide it by how many there are. How many parts did they put it into? Let's count. 1, 2, 3, 4, 5, 6 is going to equal to that X. I like to have you put the equal sign and then the unknown, which they say is X right here, because this is an equation, and equations have equal sign because we hear equal in them. If I left that off, we call that an expression. An expression is basically a number sentence without the equal sign. So then out to the side, and you're going to, and we know how to divide. We're going to divide this by 6. How many 6s go into 3? 0. How many 6s go into 30? Hopefully you said 5. And then you can do this on a scratch paper. That way, you know, you can clean it up and just put your answer here. But I'm just going to put it up front here since this is what I have. And then I bring down, subtract, bring down. How many 6s go into 12? 2. And 2 times 6 is 12. And I don't have a remainder. So my unknown X is 52. Now, if that is true, I can check this. I can take 52. That means that each of these pieces, because I put it into equal groups, is 52. And if I wanted to see how much was in there, I would take 6. These 6, 52 times 6, because there's 6 of them. And do we get 312? Yes. So when you see these strip diagrams, you've got to really help yourself by saying, am I looking for the big piece? Am I looking for a smaller piece? If I'm looking for a big piece, I'm going to be adding and multiplying. If I'm looking for a smaller piece like here, then I'm going to be either subtracting or dividing. And then seeing if they're putting it into equal groups. And that'll help you, because if they're putting something into equal groups, you're going to be dividing. But if they're putting it in equal groups, even when you're multiplying, it's going to show different things like small pieces, but they're all in equal groups, then you know you're going to be multiplying. So think of the groups as multiplying or dividing, depending on if you're getting bigger or you're getting smaller. Let's look at this next one. Here, we don't know that top strip. So to find that top strip, these pieces, they give us the small pieces that have to make up this. I bet most of you know already what we're going to be doing. We're going to take 921, and we know that if we add these, it should equal this. So since this number is small, this is a bigger number, we're going to be multiplying or adding. So take that 291, but since it's adding, it's repeated addition, we need to what? Multiply. And how many pieces do we have? So take 291 and multiply it by 3, and that's going to equal that unknown x. So put that x there. That'll help you when you get into middle school and high school. They'll think, wow, you learned so much in elementary, way past us. So then you multiply by 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 9 is 27. So then 2,763. And something else that will help is your answer will be down at the bottom. And I know I just moved that, so you can't see very well, but down here I can find 52. If 52 for my first answer wasn't down here, then I know the answer would be right. And whatever it was next to, it was next to E. So for 52, I would put in E. And I'm going to look for 2,763, and here it is. So then right here where there's a, whoops, make sure I'm on the right one. Your pencil won't move, but this smartboard does. A. So you'll put A for right here. And when you're done, this will answer that question, that silly riddle right there that we were looking at. Okay. Now, be careful because there are decimals in this one, and that's why I kind of like this one. Notice that these pieces, if I know all 3 of the small pieces, I either have to add them or I have to multiply to get that big piece. But look, are all my pieces the same? No. So here, this was an addition one. So we've done a division one, a multiplication one. But when you see pieces like this, we know this is going to be addition. Now, here's the tricky thing about it. Remember, and I know we talk about this a lot, and we even have a poster. It says if the decimal is out of sight, it's on the right. And when we add and subtract decimals, we've learned that we have to line those decimals up and put that in the place value. So here we have 89. And we're going to have to add 89 plus 112 plus 16 800 is going to equal that x. So that's your equation. Oops. And I can't write that very well. But that's your equation that you want to write in there. Okay? So that's your equation that you're adding these to equal the x. So then out to the side, and you do it on a scratch paper. Where's my decimal on 89? Well, it's out of sight, so it has to be to the right. Think about it being money. $89. You know the 9 would be in the ones place. But then we have 11 and 2/10. So now that we've seen where this decimal goes, the 2 goes here. And remember, we add up 2 numbers at a time. So in those empty places, put a 0. Since we're adding, we can just add this straight down. 2, the decimal shoots down. 9 plus 1 is 10. 8 plus 2 is 10. But now we still need to add our 16 and 800s. Look at that. Be careful. They're going to try to trick you, and you'd see if you don't know where to put your numbers. Add that 0, 8, 2, decimal 611. So the answer is 116, that's our whole, and 28 hundredths. So one good way to check to see if you got your answer right is to come down here. And since the answer is down here, then we probably did that one correct. Be careful when you're adding and subtracting decimals because they like to throw those holes in there and then we go, oh no, put that decimal at the end. If it's out of sight, it's on the right. Now, there is one more that's a little bit different that I want to go with and I wanted you to look at. Now, we see this a lot. And it's this one right here, which it says 102 on the top, and it has 14, 18 and 6 tenths, or 86 and 5 tenths, and an unknown. And we're going to write an equation for this, okay? So, here we know that there is something, our unknown is small, but we know we have something big. So we do know that we're going to be subtracting or dividing. Well, but they give us part of this down below. Some of you can kind of see this. When they do this, they give you 2 of the smaller pieces, but not that third piece. We like to have you set these up because we could understand you could take, this is going to get smaller, so we could take 102 from 14. We could take that answer and take it from 86 and 5 tenths because these are all different, so we know we're subtracting. But we'll make a lot more mistakes if we do 2 subtraction problems. Because remember, we're going from something big to something small, so we know we were subtracting or dividing, and these are not equal groups. And so that's how I knew I was going to subtract these from up here. So what's easier, and what I want you to think of is if it gives you 2 pieces down here and they're not of equal groups and things like that, then you're going to add those 2 because an addition problem is easier and we don't make as many mistakes. And then we're going to subtract all of this piece one time from the 102. Now watch, because our decimal comes into play again here, and they like to trick you with that, so don't let them be tricky. You already know where decimals go. We talk about it all the time. We talked about the first 6 weeks in our decimal unit. So I know that you know that the decimal's out of sight. It's on the right. So let's first add these 2 up, because we're going to add this up, and that's going to let us know how much all of this piece represents. Then we can take it away because we know we're going, this piece is smaller, we want to know this smaller piece, so then we can take away from the whole. So 86 and 5 tenths plus that 14, don't just stick it anywhere. If the decimal's out of sight, it's on the right. Add a what? 0. 6 and 4 is 10. 8 and 2 is 10. So then we get 105 and 2 tenths. Now I know that this represents, now this whole piece is 105 and 2 tenths. So it's almost like saying this is in 2 pieces now. Now, and adding that is a lot easier than trying to subtract each of those from 102. Now I've got my 102, and I've got to subtract 105 tenths. If the decimal, now the bigger, this top one is going to be your biggest number. It's your biggest strip. So you need to understand that this is your whole number. And there's your decimal. So here's your whole number. Let's not think that this is a bigger number because there's a decimal. Remember that decimal separates the whole from the part. You look at this right here. This is our whole. So we're going to take 100 decimal 5. Now here is the thing, and I'll use a different color. You add a 0. Because we're subtracting here, can I take nothing, 5 from nothing? Oh, if I don't fill in those with zeros, that could be, that's where they'll get you. Okay, we're not going to just bring a 5 down. So we have to come over here and borrow, go next door, get 10 more. Now 10, we can now subtract and we get 5, bring our decimal down. 1 minus nothing is 1, and this just doesn't make anything. So then my answer is going to be 1 and 5 tenths. And let's see if that's down here. It's right here, 1 and 5 tenths. So go ahead and practice with these other ones. Finish this other worksheet up. Go back to these first 4 and rewatch these 4 different types of strip diagrams. And then your independent practice will be on the same thing. So hopefully this video kind of helps you. Once again, I'm sorry for the glare. I tried everything. I'm now knowing I need to go to school to get my production degree, maybe. I don't know, with the lightings and things. So, but hopefully this will help you. Until next time.